the standard model, we need to define the concept of elementary particles and antiparticles. We're going to go over a lot of different types of particles and forces, and then go over the interactions between these particles. So, in our investigations of the standard model, we're going to define elementary particles and antiparticles. We're going to recall the 6 quarks, baryons, and mesons, the 6 leptons, and the 4 gauge bosons. There's just like a lot of different particles to remember, basically. We're going to describe the 4 different forces, the strong nuclear, weak nuclear, electromagnetic forces, and how they influence gauge bosons. The other one is the force of gravity, but we don't go into it with the standard model because it's not as relevant. It's very weak. It's a very weak force. Sorry, gravity, you're very weak. Then we're also going to investigate particle interactions, including the conservation of lepton and baryon numbers. And then we're going to investigate electron and electron interactions and electron and positron interactions, and then neutron and positron and proton decay using Feynman diagrams. So this massive table tells us about the standard model of elementary particles. Listen, I'm not going to go through all of these today just because it would be like telling you guys a big long list of names that you are never going to remember and is not going to be helpful to you. But essentially what we have is our quarks, which are the tiny particles that make up our protons and neutrons and other such particles. So these are like, if you think about the nucleus and the protons and neutrons, the quarks are the tiny particles even inside those. Oh, just banged on my table. Got so excited about the nucleus. And each of these quarks has their own like anti-quarks, right? They're like the opposite of those. We also then have our leptons, and leptons are like our separate particles. So they don't make up neutrons and protons. Our leptons are things like electrons and muons, so they're kind of separate particles. And then of course we're going to have our corresponding antiparticles for each of these. And all of our antiparticles are going to have the same mass but the opposite charge of all of our original particles. And then we also have our 4 force carriers, or our gauge bosons, and these carry our forces. So the one you might be most familiar with is the photon, which is the gauge boson for light. So basically saying light is that right? No, I don't think so. Sorry, I think I just told you guys the wrong information. Maybe it is. I'm actually not quite too sure. But basically these particles carry our 4 forces. Okay, getting onto the interactions of, no, sorry, I was right. Electromagnetic interaction is a photon. I don't know what I'm thinking. I'm very tired. So our gauge bosons are the force carriers. So they carry the forces between our other particles. So weak nuclear force and electromagnetic, and then the strong nuclear force is our gluons. We're going to delve deeper into the fundamental interactions that cause these forces, as well as investigate the standard model and particle interactions further later in year 12. So the Feynman diagrams describe what happens when elementary particles collide, and you can see a few of these over here.